So different types of questions. And the idea is that I want you guys to make sure you guys at least see a breadth of them so you guys won't be too nervous. Like this one here, it gives you a chart. And the chart ones are always slightly confusing. People feel like they're a little confused. Darn it. Let me screen capture instead. Okay, so this looks confusing, but it really isn't. Why do I say that? It's because I'm just going to answer what they asked me. Here, A. They asked me to estimate R prime. R prime, thinking back to basics, R prime is just a derivative. A derivative is another way of saying slope. So what is the slope at R2? Well, R2 doesn't even exist, but I can estimate, and the keyword is estimate here. So what is the rise over the run? That's 950 minus 1190 over 3 minus 1. And that's the answer. And make sure you show the units measured. And that's going to be liters, darn it. It's going to be liters per hour divided by hours, which is liters per hour squared. The question part B, use the left Riemann sums with the 4 subintervals to indicate by the table. Okay, so we're going to use Riemann sum for the first hour. And is this an overestimation or underestimation of the total amount of water removed? So let's worry about the first part. Riemann sums. You guys remember Riemann sums are just adding up rectangles. So the first one is going to be, the height is 1340. Second one is going down at 1190. Pen. 1340. Second one is going to be 1190. Third one's going to be 950 and 740 and 700. And the base between these values are going to be, that's going to be 0, 1, 3, 6, 8. So the base here is 1, 2, 3, and 2. And they told us left Riemann sums. So we're going to take that left number. We're going to take this left number, the left number, the left number. So let's look at another question. This question here is similar to what you guys have seen already in your graphing, where they told us this is the graph of f, but they gave us the integral for g, and g is just the integral starting from 2. Here's 2, and moving either x in the positive direction or x in the negative direction. So if I said go from the integral from 2 to 4, isn't 4 over here? So that would be this area underneath that curve, which would be the shape of a triangle, a cumulative change. What if I said go all the way up to, let's do 8. Okay, what if I go up to 8? 8's over here. So not only do we have to add values, we now have to subtract values from it. That's a negative area. But they ask us, let's look at what the information they asked us. This is no calculator. They say calculator is something you can use on AP exam, but it is not required. So does G have relative max or relative minimum? Or neither at x equals to 10? So here is x equals to 10. Now, how do I find a max or min? So that's a calculus idea. How do I find the max or min? And that should remind you to go to our first derivative, critical points. And does the slope increase from positive to negative or negative to positive? So what does the derivative at 10 look like? So g prime, what's the derivative of the integral, so d over dx, of 2 to x f of t dt. That was terrible. Let me rewrite that. So reading these questions, there's a lot of key points. Like, so if you want me to find a max or min, that I know is a first derivative. So since we're asking about g, we take the derivative of g, d over dx of the integral of 2x f of t dt. Hey, we've seen this before. Derivative of integral, fundamental, that gets plugged in. That's just f of x. What x do they want me to plug in? They want me to plug in x at 10. So what would that look like? If I plug in, look at 10, hey, that is 0. That is a critical point. Now, how does the slope change? Since we know 10 is a critical point, that's our f prime, or g prime. What's the slope on the right side? Well, that's negative slope, right? What's the slope on the left side? That's also negative. These are both negative values. We're not asking for the slope. We're saying, hey, what are those values there? So do we have a max or min or neither? This graph is going negative to negative. It's neither. And the reason why is there is no sign change at 10. 10 is F10 is a critical point, but there's no sign change. Now, what I've also included here is the answer sheet. So let's go ahead and go back. Oh, I need a screenshot. I forgot. And just like before, we have a scoring guide. If you look at my answer, what we said for A, the function g has neither a relative minimum or maximum at x equals 10, since g prime of f and what did they write? Okay, we got this part. And f is less than 0 between 8 and 10. I think it's saying it's because it's all negative. This is, they wrote it kind of weirdly here, but they're saying that it's from a negative to negative. Okay. If you wrote it out separately, you wrote f is less than, oops, separate f is less than 0 between 8 and 10, and f is less than 0 for 10, 12. You can write that too. So my encouragement right now is for you guys to go ahead and spend time going through all these types of questions. Like, there are, if you guys look at the number I've included, there are 6 tests with really about anywhere from 4 to 5 questions, 3 to 5. So if you just do the ones I recommend, it's 5, 10, 14, 17 questions, right? To just see a breadth of it. Also, I've included all the other FAQs if you guys haven't done them yet. I have one more I should upload, which is related rates. How are you guys with related rates? Any good? You guys remember related rates?
No.
I don't know.
No? Related rates was that example of the sliding ladder. You guys ever see that sliding ladder example? No? Related rates. Oh no. Okay, shoot. Let me see. Let me show you guys. Okay, I'm gonna add this to the class real quick. Just included in my other class. Give me 1 second. I'm going to pull up the worksheet for later. You know what? Let me see if I have it with me right now. This is related rates. Okay. This is like first semester stuff. You guys think it's related rates? Okay. Here is the example here. A square is inscribed inside a circle. And there again, there's a lot of different types. There's like 3 4 main types of related rates questions. And it has to do with a rate. Rate meaning like miles per hour or centimeters per minute. It's based on some type of change based on time. That's what the definition of rate is. It's based on time. So let's take this example. A square is inscribed inside a circle. The radius of a circle is increasing. The radius of the circle, we'll call this radius here. This is the radius, r, is increasing at a constant rate of 0.8 centimeters per second. So for these types of questions, rate is defined by dr over dt. So we're going to write it in a calculus way, meaning a change in r over a change in time. Think of miles per hour. Miles per hour, it's a change in miles over a change in an hour. I drove 300 miles in 3 hours. That's a change in distance over change in time. So for related rates, you always end up with these derivatives. And kind of the cool thing is that they're very straightforward. This is the rate. And the rate here is 0.8 centimeters per second. Okay, that was given to us. Also, this is given to us as a square. That's a square I'm going to call it SNX, just so you guys can see that. Now, the question will then say, when the side of the square is 4 centimeters, what is the area of the circle? Okay, very simple. If the side of the circle is 4 centimeters, what would the area of the circle be? Well, the area of a circle is a is equal to pi r squared. Now, a big deal for related rates is writing equations. They're almost always geometric equations. So area of a circle is pi r squared. So we have to somehow get from S to R. Now, using everything I've learned from geometry and pre-calc, I see that is a square with a side 4. And if I cut in half, I end up with a right triangle, a 45, 45, 90 right triangle, which is a special type of triangle. So this is going to be, the whole side is 4 square root of 2. This whole thing is 4 square root of 2. You guys remember that? 45, 45, 90. You know the sides, you know the hypotenuse. And the radius would be half of that. So r is equal to 2 square root of 2. So the area of the circle is pi r squared, which is this, square root of 2 squared. Okay, so that really isn't the related rates question. The related rates question is the next one. Here's this. So there's a hint to almost all related rates questions. Is you're going to take the derivative. We have to start off with here. Okay, let's start off with a starting equation. So let's read this next part. When the side of a square is 4 centimeters, what is the rate of change in area of a circle? And that is the gimmick here. That is the key. What is the rate of change of area? If you go back, remember I said the constant rate of the radius was dr dt? Whenever you hear the rate, we're going to write that as a derivative. This is going to be rate of change of area is dA over dt. You want to make sure you write that. I'm looking for dA dt. Now, how can we get from what we have on this page already that you guys see to get to dA dt? What could I take the derivative of to get dA dt? Well, the derivative of area. See, I just need the derivative of area. So I have to go back here, looking at this equation, and actually take that derivative. So let's try it. The derivative of a, dA over dt, is equal to the derivative of pi r squared. So if you look here, I just took the derivative to both sides. I just took the derivative to both sides. So what's the derivative of A? Just dA dt. Don't overthink it. The derivative of X is dx dt. Let's take the derivative of pi r squared. Pi is a constant. What's the derivative of r squared? Since that's a variable, we have to use power rule. That's going to be 2r. Chain rule. Derivative of r is dr over dt. Does anyone need help with the derivative on that right side? I can do it with another example. Anyone need me to do this with another example real quick? Or okay with that derivative on the right side? Okay. So just as a side note, if you were given a problem that requires a Pythagorean theorem, a squared plus b equals, let's say, h squared. Okay, if I ask you to take the derivative of this, d over dt, okay, we're going to do exactly the same thing. The derivative of x squared is 2x dx over dt because of chain rule. Let me take my time here. Let me zoom in. The derivative of an exponent moves it to the front. That's why it's now just an invisible one. Then what's the derivative of the inside chain rule? Is dx dt. Let's do it again for the plus 2, but plus y squared. The derivative of y squared is 2y. What's the derivative of y? dy over dt. What's the derivative of h squared? It's 2h dh over dt. Let's talk about a dumb one. Okay, this has nothing to do with anything almost. But what if I ask you, what's the derivative of force? You guys remember in physics or in physical science, F equals to ma, mass times acceleration. So if I take the derivative of this, so if they're multiplying, that's product rule. Derivative of the front, leave the back alone, plus the derivative of the back, leave the front alone. So the goal here is to realize, don't overthink it. Just take a derivative the way you normally would take a derivative implicitly. Okay, let's go back. Okay, now here is the next crazy part. Remember, solve what they're asking us to solve. They're asking us to solve for dA of dt. Hey, we have that already. Good job. Now we need to plug in some variables. Did they tell us what dr dt was? Well, did they tell us what dr dt was? They did. Did they tell us what the radius was? No. But in our last question, we did find out what the radius was. So all we do is we just plug in those values. Equals to pi times 2 squared of 2, and 0.8. And now they want us using correct units. Just make sure these were in, I think, centimeters. That's centimeters. And that says centimeters over seconds, was it? Centimeters over seconds. So back to physics or chemistry. Remember, we're just combining our units. That's going to be 16 pi. Oh, that's, sorry, 2 and 2. 16 times 2 is 32. Let's multiply the numbers together. 2 times 2 times 8 is 32 pi squared of 2. And we're left with centimeters squared over seconds, which makes sense because we're looking at area. Area is a squared unit. We're right clear here. All right. Any questions or where were you stuck in this process? Have you guys seen this before, related rates? No? Again, back to no. Okay. So this question I'll post up. This question, and I'll post up a couple of them like this. Related rates, is takes some time to get used to, but once you get used to it, it's just really, it's almost like just answering what they ask. They want change in area, I'll give you change in area. Okay? Not trying to overthink it. This one is similar to that. I do these questions. Actually, you know what? I think I have the video. Maybe I'll post up the video with this. Okay. You know what? I'll go over this one right now. I think this is a very popular type of free response question, conical tank. And there's actually only one main gimmick to this problem. Well, two other gimmicks. So water is poured into a conical tank that is 24 feet tall. So this is 24. I'm going to write 24 here. And the top is the diameter. Here's the, you know what? I hate it when they do this. Say the diameter is 20 feet. So the freaking radius, and I say freaking because I always mess up here. I always forget to change it. And the radius is actually 10 feet. Okay? That's very important. This is super important. Okay, the height is 24 and the radius is 10. They also gave us their volume equation here. Thank you very much. Now in this statement, write the formula for the volume of the cone of water in terms of H. So that's write the volume equation. Let's look at the volume equation on top. And the volume is in terms of R and H. But they just said, write this only in terms of H. And this is the gimmick for solving these types of volume questions. You want to change R to H or H to R. Now, how will we do this? It's not like we just know what H and R are. What we do is, here is our gimmick. I'm going to draw you guys a new triangle here. See this new triangle here? This is my new triangle. And this triangle and the big triangle from geometry, there's a term for them. Remember similar triangles? So these are actually similar triangles. So here is the gimmick. I'm going to call this little r, and I'm going to call this little h. Okay? So since they have the same ratio, this is what you write. You write r over h is equal to 10 over 24. I want you guys to see what I just did there. This is almost what you always do. We have v is equal to 1/3 pi r squared h. And we want to make all our r's into h's. What would r equal to in terms of h? R in terms of h. What would r be in terms of h? So here we go. R, let's solve for r in terms of h. If I simplify this, this will become r over h is equal to 5 over 12 divided by 2. If I'm solving for r is equal to 5h over 10, or sorry, 12. R is equal to 5 over 12h. Is everyone okay with how I use the similar triangles to find out what r would be in terms of h? Because my next step is to just plug it in. R is now 5h's over 12. This is squared. No longer is this in terms of r, but this is all only in terms of h. I'm going to pause there for 1 second. Does anyone have a question how I made r into h? Okay. Give you just a quick example on the side. If I gave you a different cone, and I told you the height here and the radius was 5 and 4, okay? You would still the same thing. You would call this r and h, small version of the triangle, and r over h would equal to, in this case, radius is 4 over 5. They're similar triangles. And if you want to solve for r is equal to 4 over 5h. And you would plug that into this equation over here. Always that case. What if you want to solve for h instead? Fine. Erase this. Oh, let me write this in blue, actually. I'll leave it. This is in blue. If I write h over r, that's 5 over 4, because h and 5 are the corresponding sides, and r and 4 are the corresponding sides. So h would become r, sorry, oops, 5r over 4. So we could plug in h there, and we can write in terms of r. Okay, this is what they wanted. Yeah, pretty much. So that we can plug in. See, if I have r, I can plug it in to get h. We first set up the ratio so that we can solve for one side. And in this case, I move the h over, yes. Or if you want to move the r over, you can. Whichever one you want to move. Okay? So if you look at this problem now, no more r's. There are no more r's here. We can write everything in terms of h. And the important part of this is because when you take a derivative, do you want to have more than one variable on that one side? Let me give you an example up here. If I write the derivative, okay, let's take the derivative of x times x squared, or would you rather have derivative dt of x times y squared? Which one is easier? Of course, when they're the same variable. First one, right? So if there's a second variable, you have to actually remember write it separately using product rule, which is too much work. So our goal is to write, instead of r and h, to just write that in one variable. Okay? And that's what this problem is kind of coaching you into. Now, let's go to read the problem. The volume of water is increasing. Volume increasing. Keywords. Volume increasing. That is a rate. So automatically I'm going to write, since that's a rate, dv over dt is equal to increasing. That's a positive. Make sure you see that's positive. Increasing. 3.4 cubic feet, which is feet cubed, over a minute. And the height of the water is 2. H is equal to 2. Guess what? For us to find volume here, we need H is 2, right? We need to find the H value. They gave us that value. At what rate is the height up? See, that's the gimmick right here. At what rate is the height of the water changing? So looking back at the equation we just wrote up here, they want rate of height. Rate of height is dH over dt. Don't be fooled. They told us exactly what they want. They want dH dt. I do not have dH dt. We will need to find it. How do I get from h to dH dt? We just take the derivative. So I'm going to simplify this equation up here to make it a little pretty. You don't have to, but I'm going to do it. So 5 times 5 is 25 on top. And 12 times 12 is 144. 3 times 144, I'm too lazy. 144. Okay? And we're going to say pi h cubed. Okay. Everyone okay with that simplified equation? Looking back on top, 5 times 5 is 25. Move that to the front. 12 times 12 is 144. Move that to the front with a 3. I'm too lazy to multiply it together. I would recommend not to. We have a pi and an h cubed now. Now, in order to get dH dt, we're going to have to take the derivative. So that's take the derivative. The derivative, so you don't have to write this stuff. I'm going to write it because I want you guys to see what I'm doing. I'm taking the derivative to both sides. 25 over 3 times 144 pi h cubed. Okay. I'm literally taking the derivative to both sides because I need to, look, dv dt, I need that. dH dt, I need that. And the only way for me to get there is through a derivative. So here we go. Let's take the derivative. The derivative of v is simply dv over dt. On the right, the derivative of 25 over 3, don't do quotient. That's just a constant. Leave that alone. You get left alone. Pi is a constant, left alone. What's the derivative of h cubed? Power rule. That's going to be 3h squared. Chain rule. dh over dt. I would practice that on your own like 2 or 3 times so you get that method. It's actually not very hard, but we do forget parts. Okay, final question. What is the rate of height? Okay, what's the rate of height? That's this guy here. Well, to solve for that, do we have the rest of the variables? Do we have dv dt? Do we have h? And guess what? We do. We have our h value here, which is 2 feet. That's the height of the water. Do we have the dv dt? Yep, we have that. So for us to get this right, we don't need to do the math, but we need to move stuff around. So a couple things are, if you look here, I have a 3 and 3. Those are going to divide out. I'm glad I didn't multiply those out. We know h is 2. That becomes a 4. We know dv dt is some crazy number. So let's rewrite this. This would be 3.4 equals to, that's right, this is 4, right? 4 times 25 is 100 over 144. You can reduce that. I'm not. And then dh over dt. To solve for dh dt, I'm going to kick everyone to the other side. This is going to be 3.4, 144 on top, over 100 on the bottom, pi equals to dh over dt. That is our answer. I'm not going to simplify anymore. I might make a mistake. Okay. Whew, that was a lot. Any questions on any particular step or clarifying questions? Okay. So the last one is very similar to that. It's a surface. If you guys want, I'll include the YouTube video in the link. I did it with the other class. But I also include the rubric, so I'll put this up too, so you guys can take a look at it. I also, yeah, let's go back and take a look now. So you guys have, I feel like a lot of stuff that you guys can work on to prep for that test. The FRQ is pretty much it. And we'll worry about after the test, I will be posting on Schoology some Zoom times over the weekend in case you guys have questions for me. You guys want to work out some FRQ questions. So I'll post those. And if you guys want, you guys can join us. Okay. And I'll record them also, and I'll just post them on the website. Any questions? You're okay? All right. Thank you very much, folks. Sorry, we kind of had a lot of stuff to do, I guess. But it's time to review now. Great. See you guys. Have a great day.